Hello everyone, we are from Team Group. Today we are going to
Justin.
share. Yes,
Justin.
today we are going to share the game named Angry Bird. It was launched at 2009 by Rovio Entertainment. It was a hit in many people's childhood. This is the original version with the simplest play method. And besides the original version, there are many new mechanisms updated in other versions, such as space field and water buoyancy in the water. As the pictures and videos I show here, we can see Rovio preferred to integrate physical phenomena into their game as their fundamental game. So today we are going to check and analyze if the check of the birds is reasonable. And all the birds in this game with their own special abilities, such as, for example, the black bird can blast and the orange one can swell immediately. This is not the original one. Oh, yeah, it is. And the white bird can lay an egg and it will fly toward the upright. And the blue can separate into three. The players need to drag the birds on the slingshot. Then we need to project it to damage the pigs, hide behind the buildings or the terrains, and tap the spring at the right moment to induce their skills is very important. So let's show the physical formulas can consist with their skills. The first one is position projection function. And before the skills being activated, all the birds checks is consistent with these functions, but they with different velocities. So we can see the list before all the birds with the different velocity v0, and the theta is depending on how we drag the slingshot. And the variables x and y express the position, their two-dimensional positions. When it comes to white birds, because it can lay an egg and then change its track of its motion, so we think the collision function is the best way to predict its motion check.
So can you show the video of the white bird? What do you mean by laying egg?
Laying an egg here.
Huh?
So the egg will directly down and it will fly upright. And at that moment, I think it's a momentum conservation, right?
So when it lays an egg, it went up. How?
Yes. How? It's skills, so I think you need to ask its developer.
Well, you chose this game, right?
And yes.
So can you explain in physics?
You mean why? We will say behind the later.
Okay.
Yes, we will give a precise explanation for it.
Good. Very nice.
It's just a simply briefly view for everyone.
Hey, can I see the blue one too?
Okay.
So the
It
blue
will
one.
separate into three.
Oh, okay.
So maybe we can So
And the orange one, what happens to orange one?
orange one will swell immediately,
Oh, so it's like a bomb.
like this. But if we say bump, we will turn the right one. It's a real bump.
Can you show it again? So the orange one becomes bigger?
Yeah, orange one becomes big. Just like the green.
Wait, that orange one that went out?
And yes, because it, maybe when it's swelling, it hit the ground and
Okay,
bounce out.
okay.
And this is the projection formula we say, and the collision. Though the white bird is not collision, it's a fission. It will separate in two parts. But I think it's in the same concept. Right. The
So,
yellow.
what was the point of the previous one? So what's the point here? So you're explaining white one here?
No. What's your name? Stanley will explain this part
In detail.
in detail.
Okay, okay. So you don't have to answer my questions. Stanley will.
Yes. And for the yellow bird, its skill is acceleration. So when its skills work, it will do a straight line motion with the direction of its tangent line. So if you fly to here and we tap the spring, it will fly in this way.
Okay, so the yellow bar is what? Yellow is just a normal one?
Yellow is the normal one. No, red is the normal one with no skills. But we will see,
Okay.
but we will say later because I just do the introduction for
Okay.
all birds and the formula we concerned about.
Okay, so who's going to explain this?
This is yellow. And no? Elbow.
Okay, good, okay.
Okay, the last one bird is green bird, and it moves like a boomerang do.
Mhm.
So we think the aerodynamics and the centripetal formula. This is a good solution to explain how it's moved.
Okay, can you show the green one?
Okay, actually,
And the green
We
one.
have it. Okay. We have a movie for green one?
Yeah, they are moving.
Okay, Justin, are you gonna come back later or finish?
actually, I finished because I do
Okay.
an introduction and for all the formulas collection.
So no physics in your part?
Yes.
Okay, your homework, find what's wrong with something wrong with others' presentation. and
Okay.
Add it to the report. Okay,
Okay.
okay, who's next? Rora?
Yeah.
Okay,
So, okay, the first bird we're going to talk about is the red bird, and it just named red. And
okay,
the
red one?
video is the horizontal motion. And it looks kind of disruptive, but actually I believe it's very useful in the game since it doesn't have any special skills. So we
Okay.
just discuss about the projectile motion of it.
Mhm.
And the motion is comes from the slingshot, giving it the initial velocity so that it can fly. And depending on the launch angle, it would have different position and velocities. So let's break down this motion in more detail. So firstly, we can see the velocity, and in the projectile motion, the horizontal part and the vertical part would they are independent, which means that they don't affect each other. So we can discuss them separately. So for the horizontal part, the velocity Vx would be the constant V0 cosine theta. since it doesn't have any external force act on it. And on the other hand, of the vertical part, Vy is which does the constant acceleration motion by gravity. So the value of it would be the V0 sine theta minus gt. And just like the GIF shows, the Vx would be the constant, and the Vy, firstly, it would be upwards and decrease its values until the highest point. And after that, it would become downwards, and the value of velocity would increases. And after we know the time, we can calculate the time. After we know the velocity, we can calculate the time. And because we know that the Vy is through the constant acceleration motion, so we know the initial velocity and we know the final velocity is 0, so we can have the difference between them is V0 sine theta, and which is divided by the acceleration, which is g, and we can know the half time, and so we times it times 2, we can get the total time. Then we, because we know the velocity and we know the time, so we can just get the range R, which means the horizontal displacement, by times velocity with time. So the V0 cosine theta is the velocity, constant velocity in Vx, and the other part 2 V0 sine theta divided by g is the time. So we multiply them, then we can get the range. We can also get the height from the emotion we know from until now. And we can get it by 2 methods. The first one is because we know that the Vy is due to the constant acceleration motion, so we can draw the VT graph, and we know that under the graph it's the displacement, and which means height in this situation. So the V0 is V0 sine theta, and the velocity is V0 sine theta, and the time is half time, because we just need the initial part to the highest point. So the time, half time is V0 sine theta divided by g. And we can multiply them and divide it to obtain the triangle area, just like this. So it's the first method. And the next method is that because we know that there's no external force involved in the motion, so the energy is conserved. So it means that kinetic energy simply transforms into the potential energy. So, and vice versa. So at the lowest point, the potential energy is 0, so it only have the kinetic energy. And at the highest points, the kinetic energy is 0 in the vertical part, so we only have the potential energy. So arrange this equation, we can get height from as the same as the previous one. Okay, so next we can discuss the relationship between the launch angle and the horizontal position R. And because we know the R's formula, so we can know that the maximum of R, which means the Fourier displacement, is V0, the square of V0 divided by G. And this happens when the theta is 45 degrees, because at that point the sine to theta would be the 1. And if furthermore, if the theta 1 equal and theta 2 is complementary, which means that their sum is 90. The range R would be the same because their sine to theta is equal. Okay, the last part of the red bird is a fun fact because when when the game is very popular and there's some crazy person, they calculate they analyze the whole motion of the Angry Bird, and the result they obtain is that no matter what angle, the max speed is 22 meters per second. And I think it makes sense because I think the max velocity is happened just its initial velocity. So maybe the developers just set initial velocity in the game. Maybe it's my thought. So okay, it's my part.
Okay. Laura, what happens if you add air? So you're ignoring the air resistance, right? Air resistance. What happens if you add air resistance? Air resistance.
Yeah, I ignore.
Here, please add it. Can you add it?
You mean that if add the air, how the motion
Yes.
would become?
Yes.
I think because there's because the resistance, there's some energy would disappear.
Mhm.
Yeah, so we can because if I ignore it, the velocity here in the initial and at its start and the end would be the same. But if we have the resistance, the velocity would be smaller.
How much?
How much?
Hmm.
I don't remember the formula of the.
Okay, homework. So you showed a lot of equations, right? Very good. All of them, please add air resistance and then see how much the number changes. Okay, good.
Thank you.
Very good, Laura.
Okay, now this added, and I want to tell about the green bird. And we can see this demo video. And you may figure out the bird action like your all toys that you ever played. So that toy we call it boomerang.
So can you show that?
Oh,
I
okay,
missed the first
sorry.
one.
So you can just, you will return it back. Yeah.
Oh, you push it again and it comes back.
Yeah.
So you have to push again.
Yeah, push again and you will acting like boomerang.
Oh, okay.
Yeah, that's this bird. This behavior. And just my partner mentioned there's a little bit about the centripetal forces. And this forces is caused by the aerodynamic, and I will give a brief introduction about it. And the second one is caused by the moment, or sometimes we call it torque. And just have a brief introduction about the aerodynamic. So the gravity is a force that pulls toward to the earth. And the lift, so it is against the gravity. The drag is the sum of the air force that will resist the object movement. And the thrust is just for the boomerang issue because we give a force to the boomerang. So the thrust is also given by ourselves. And this is the bird behavior. You can feel that it's just like the boomerang, right? It is very simple.
Oh, okay.
And there's a equation. Well, it's some back here, so there is a little bit not display on there, but that's okay. So you can figure out the lift equation and the drag equation, and you have the both same, the 1 divided by 2 rho b squared and times area. Just like the coefficient of lift and the coefficient of drag is different. And now I want to give a
Sure.
short.
So what is? Can you explain what is L you're calculating?
L is the lift, so we can
Okay.
calculate the lift.
Okay.
And the drag because there is some type of air resistance, right? And we can put out the coefficient of the jack. Yeah.
So A is what area?
Area is the area is there. It's just the surface area. The airport is attached.
You mean the front or
The wing area. That's a great question. I think I need to figure out the data. Yeah, because I didn't know is it for the upper side or the downside of all of the area. Yes, I think I need to figure out later, and I will also write in my report. Okay.
that's good, that's good. So the
Sorry.
the- so where does the shape of the wing comes in?
Shape of the wing.
Yeah.
The Air Force will just attach on the wing.
I mean, say the wing is usually this kind of shape, right?
Yeah.
If it's a square or cube, then it's not going to give you any lift, right?
Yeah.
But
so
it
I
should
will-
have it should have area, right? So
Well, if the Air Force will attach on the surface or not, I will use the Bernoulli principle there to explain the phenomenon of those the Air Force on the surface.
you're going to explain that now?
No, later, because I do my slide later. But now I just want to talk about a little bit.
Yeah, okay. So the coefficient depends on what?
Depends
So,
on.
so go. Okay, you're going to explain.
Yeah.
Can you go back?
Oh, okay.
So what is the definition of Q?
Two.
Oh.
There's a dynamic pressure. Well, dynamic pressure is like right on this one. It's based on the larger density and the velocity. So you just write down like this.
Okay, I see. Okay.
Okay, so I just want to. Can I go on?
Not yet. Yeah, so here it's probably this side.
So
Area. Yeah, maybe. Okay, and then can you explain the Dirac equation next?
transaction.
Hmm.
Well, that's because some Air Force didn't like the wind going. So this kind of resistance. But they use the same equation to explain it. But the coefficient, like next I want to mention, is different based on the angle of attack. Can I go on the next slide? Yes, it's just the angle of attack. There is the angle that related to the wind, so there is the angle of attack. And this the figure I found on Wikipedia, and it told us that if we had increased the angle of attack, the coefficient of jack, and then they are also
So what is y-axis? What is y-axis? I cannot see.
white.
Y-axis.
Oh, sorry. I mean, that is the jack coefficient of jack.
Okay.
Sorry, because there is a discrete problem also on my presentation slide. Yeah. So
Okay.
here is the jack coefficient of jack, and then and moving. And although the jack and the
Why do you need it? The numbers are different between CL and the CD.
CL and CD,
Oh.
the D,
So you have three numbers in y-axis, right?
yeah,
0.02, 0.22. So what's the difference?
so if the jack is massive
No, I'm talking about the number.
number,
Yeah, y-axis unit, I'm asking.
then the coefficient number.
Yeah, I'm asking unit.
Unit.
Oh.
Good question, because they didn't show. It always
It shows in y-axis, no? If you don't hide it, can you move the picture a little bit?
No, well, because it's presentation, I'm afraid I will miss out something, but I can show the
Okay,
the raw pages to you.
okay.
Okay, so just wait a second, okay? There's the origin data.
But it's,
We just learned the side This coefficient of jack.
okay, so my question is why why the image is different, the numbers are different? Yeah, I'm curious.
Well, as I know, because the angle of the tag, although the coefficient of jack is sometimes it depends on the angle of the tag, but there is another formula to talk about for how to find the coefficient of jack to cross it. And as I remember, but I didn't put on my slide, and it's depending on the surface area and some of your velocity. But I think I can also put on my regular report. Yeah.
That's good, yeah.
Alright, so
Wait, you haven't finished, right?
Oh, yeah.
Can you finish explaining it?
yeah, actually,
So what's the different colors?
different color.
Wait, different colors, those different numbers are for different colors, no?
Well, just because I just want to mention, this is a jack one, the yellow one or the orange one is a jack, and the red one is the coefficient of that. And this
Okay.
one we just divided by each other, and there is. I think I need to visualize. I just my report. I just want to mention the angle of the change of the angle will cause a different kind of coordinate change. Yeah.
Okay, so that explains my first question, right? So the leftmost one is for orange, the red one is for CL,
Yeah.
and then the rightmost one is ratio.
Yeah.
Okay, so now why the CL has a peak there?
Well, because we use the L divided by drag
No, I'm not talking about L divided by that. I'm talking about CL.
CL.
A peak, there's max, right? You wrote that, right?
Yeah.
So why there's a peak?
Well, if your angle is very long, the air resistance will also get high. I mean, because the air flow was just going down here, and the lift will just, because the air flows were going just like this one. It's going down, your air flow going down, and the lift will just cause will decrease.
How?
Well, I think I need some video later, but I didn't put on my side. Yeah.
Okay, this is very important. Could you add this in your report? Can you explain why CL has a max at 20 degrees? Okay, I'll not take a note here, so that's most important homework.
Okay, I see.
Okay, now,
Sorry.
wait, you haven't finished. Can you explain the CD's behavior?
CD? Just because if your angle just going increase your angle, the down surface and attach more the air force, and it will cause the resistance.
Okay.
Will be increasing, just like this curve, which is a very awkward one. Yeah.
Okay.
Okay, so can I go on?
Yes.
Okay. So there is the air force, and the air force will attach on the surface, and it will cause your object will go up. So sometimes we call it or just go down, and sometimes it's just going crashing. And that's why. Well, I use the Bernoulli principle to explain this kind of phenomenon. And we suppose an ideal flow with the constant speed of initially, and the point at the faster speed will have a lower pressure. And because the air wind, the outer surface has a long path of the bottom surface, and you can find out that there is more air force on the top. And you may figure out that the velocity will be faster than the downward one. So by the Bernoulli principle, we can figure out the pressure on the top, it will be lower than bottom. And there's the equation there. I will give the derivation later because you will figure out why the kinetic and potential energy and pressure will open. So there's a very quick dimension. If you give a force to the object also has a kinetic kinetic energy and potential energy. And we all know the work is equal to the force times distance, and the force is also equal to the pressure times the surface area. So we can write out our equation like this one. And the second one, we can put our kinetic energy and our potential energy to explain it, to put the equation to our this formula. And we need to suppose the fluid is compressible. And now you may feel strange, right? Because the air is compressible, right? And that is actually if the air velocity is lower than 100 meters per second, that means your mass number and ACH. Mass number is lower than 0.3. And the mass number is the measure of the compressibility characteristic. And at this case, we can, because the boomerang didn't fly over the 100 meters per second, right? Because we didn't get enough force. And so we can treat the air in this case is incompressible. So that the equation we can use on our boomerang system. And because we suppose this one, so we can just add the streamline to get the P plus the 1 divided by 2 rho B squared plus rho GH is a constant. Well, I think I just skipped a little bit more step, but I just write all of the 3 points on my slide. Yeah. And now you may figure out why the air force will stay on the wing. And there's a effect we call conduct. And the merry-go-round is able just to turn on the tap, the water will fall down, right? But at that time, if you put your spoon on the surface, attach the water will just along with your spoon surface. And in some kind of can use the Newton first law to explain it. Because I give a force to the object will also give a force to me. So that is very easy to understand. Yeah, so that is the conduct effect. Yeah. And now the second part I want to measure about the moment, or sometimes we call torque. Because actually the boomerang has different kind of air shape, the wing shape on each other side. And because there's a variety different kind of air force, just like this one, well, a little bit up here. That's okay. Because there's a variety different kind of air force, they are called the differences of velocity. And you can figure out the velocity here will be faster and this one will be shorter. So they cause the different kind of force to let them rotate. And the different kind of the force they will cause the precision torque and also have the angle velocity. So they can just rotate it. And just by the angle velocity, so we will just, if you're flying up to there, and you will just try to go back because the force just going to the near side, so you will just going back.
So can you explain again? So, can you explain why it's so there's a torque? Okay, why it changes the direction? Can you explain again?
Change the direction? Well, just because there is just your force given by the one that there is all rotating, right?
No.
Plus the aerodynamic, the Bernoulli principle, so they will just rotating, they'll try to rotating to cause the difference of the angle velocity and the precision of torque, just because there is the different depth force to cause it.
Why did the force is different between A and B?
Just because the air shape then exists on the different side of the boomerang. And if your air is thrown by this side, it will be faster, but another side will be lower. Just when you're rotating, there's a far different. Although there's a far different, the same air force, but they cause a different kind of effect. So they will call the difference in the velocity.
But the rotating speed is the same.
Yeah,
So
but
why is it different?
because the air, maybe some object or some resistance that will cause the boomerang has the fixed kind of effect. Yeah, that's my option.
So the boomerang is always this kind of shape, right?
Yeah.
Why it cannot be straight line like that?
Train. Do we just right for something they will go train?
Oh,
Or I think just the shape on the book will very design. Yeah, and this design will cause can cause some different kind of force on each other or side, and that will cause your object rotating back because there is an angle velocity.
okay. So it's okay if it's a stick, not just this bended shape, but if it's stick, it's okay. Still, it comes back.
Hmm?
If it's a stick, still come back.
If the stick is
So the boomerang is this kind of shape, right?
yeah,
It's bended, right? So you make it straight line.
Hmm.
Does it still come back? According to your explanation, it's still right.
yeah. Actually, the shape it didn't matter. I mean, this shape it even the cause of what have the same effect just becomes just the weight. The weight is size. Just always on the weight is size. Yeah, not a shape problem because you may see that of the boomerang and that of the shape, right? Just this one is just one of the famous one. But we can see another one, just another closely, and another maybe I don't know. But they are different kind of shape, but all of the key point just because they cause the different kind of different they cause the different velocity on each of the side, and then we'll try to cause the torque and the angular velocity.
Okay, good answer. So now, what kind of things cause this velocity difference? So if you're going to make boomerang by yourself, what's the most important thing here?
If you use the paper or some of the object to use it, maybe you need to just throw it a little bit to let there have a kind of air shape. They were causing there's not a demo here, but you can just use some paper on it and just throw it, and you can just maybe just throw it just like there,
Mhm.
and just have a different kind of the shape, and you will cause you will have the boomerang effect just because you just have the wing there.
Okay.
Yeah.
Very good answer. Good. Very nice.
Okay, so there is an incredibly child to ask me, and because we throw our boomerang in the velocity, right? But just like the demo showed, because we throw it for a while, but it come back with a while. And my opinion is that because there is a jack, right? And the jack has some of the resistance, because although the boomerang position will try to against this kind of force, but because the energy will lose it because of the resistance. So that will just like the telescope, right? If your telescope is rotating, but if there's a force on the table, so you have gravity, so that now just a little bit later will go down, right? So the same idea is happen on the boomerang. So there is a jack and some kind of air resistance that will cause your object will be wider. So yeah, if just like this, then will show that if you follow the vertically and your object is going to be horizontal. So that's my answer about this question.
Okay.
Yes, I
Fine.
think. Yeah, I think that's that is all my part because my time is just my time just waste a lot. Yes, I think I need to give my another partner here.
Well, if you can explain the last part
Last part,
in more detail, that would be better.
this one.
I don't know, not the one before. You didn't use any
Oh.
the one before. You didn't use any equations to show us, right? So
Yeah.
that would be better.
Because there's always maybe some child will ask, right? And because I found on the internet, well, they also give a little bit just a little bit discussion about this. Like maybe we should just talk about the position and the air resistance. So I just create just like this slide. I didn't put the formula on my slide, and I think the formula for the resistance is maybe it's difficult for me.
Okay.
Yeah.
Okay, but your presentation was good. Yeah. So please read out about the CL max. Okay.
Okay, I'll write down.
Very good, Alan. Thank you.
Okay.
Then who's next?
Albert.
Albert, yes.
I will introduce this yellow bird.
Yellow.
It's
Sorry,
not
could you remind me what's special about yellow? Is it everyone? Or no?
chocolate. Huh?
I'm not asking about the name. What is the special about the other one?
它是说你的保色。Well, the video just made, but I think we can see the video later because the internet connection.
Okay.
Just like
好，its function is to accelerate when we press the
这样暂停。
We
let's take
accelerate in the middle.
let's take a short video.
Okay.
Okay, 好，
Did it accelerate?
好 ，it's my observation after we press the switch.
Sorry, in the previous, where did you push the screen?
Okay, 就是
Oh,
it's
I see
the
a stop. Okay.
好，OK, next.
Okay. That's interesting.
It's my observation. It's my observation. After we press the switch, the truck will move forward along the tangent direction at that point. This is the point. This.
Mhm.
Next, I want to discuss about this special case. Okay. When we are playing this game, sometimes there is error between the predicted locus. This is the predicted locus. Predict. Okay. Between the actual locus. Okay. Okay. Which results in failing to hit the peak. Okay. I need to explain one more time.
No. Go ahead.
Okay. Hence, I try to build a mathematical model to solve this problem. It's my setting. First, I set the beginning location of truck is origin. Initial velocity and gravitational accelerating is setting as above previous. Next, the angle between speeding and the horizontal direction is theta. Theta is this. Okay. By our previous introduction, we know that Roche equation is this. Next, I try to compute the equation of tangent line as 1 by 1 at some point. So this equation is this. The slope of this is to differentiate y2x. By differentiate y2x, we can get this. By computing the equation of tangent line, we can predict the equation, the locus of center line to hit the tip. It's my, this is my assumption. Okay, it's my part.
Hey, you finished already?
I focus on the moment of the truck.
Yeah, but I mean, this is very similar to roller, right? Okay. Your homework. How can it accelerate? Figure out a possible acceleration mechanism. Is that physical or not? Okay. You come up how to accelerate. Okay. This is very important. Okay, I cannot give you a very good point now. So it's very important for you to do the homework. And then spend time and do a very good homework. Then I give you a good score. Okay?
Okay.
Because I don't see very good thing here. So okay. This is very important. Okay. So
Okay.
please make sure you do your homework. Okay.
Thanks.
Good. Thank you, Albert.
And I'm Stanley,
Okay.
and I'm going to talk about Matilda. And we can see the video that is the whole
Acorn.
she will lay an egg and make herself flying high.
Can you see that again? Show it again. Okay, good. You're going to explain it.
And as we can see, the bird and the egg change the direction after using the power. Because after using the power, the direction and the value of velocity of egg and bird will change. And there's a question that what is the relationship between the velocity of egg and the bird? And we can solve the equation by using the law of conservation of momentum to estimate. And when a system that it does not act on by the external force, then the sum of the object in this system will be constant, and this is this equation. And since we know the momentum is mass multiplied by the velocity, so we can write it as this. And now we are going to talk some application of conservation of momentum. And the first we're going to talk is collision, since the collision is the most common example for conservation of momentum. And there are 3 different types of collision. And we talk the elasticity first. When the sum of kinetic energy of object in the system doesn't change after collision, we call it elastic. And if we lost the kinetic energy after the collision, we will call it the inelastic. And when the collision lost the most kinetic energy, we will call it perfectly inelastic. And after a perfectly inelastic collision, the relative velocity for object 1 and object 2 will equal to 0. And there are 2 types of collision will lose kinetic energy. Since there is no external force during the collision, so all of these 3 types of collision will follow law of conservation of momentum. And we can, if we want to distinguish which type of collision it is, we can use the coefficient of residuation to check what type of collision it is. And here's the formula for coefficient of residuation when with first one-dimensional collision. And the 1 and 2 here means the object 1 and object 2, and I and F means the initial velocity and final velocity. And if the CR equal to 1, then it will be an elastic collision. And if CR between 0 and 1, it will be inelastic collision. And if CR be equal to 0, then it is perfectly inelastic collision. And here are the other two applications of conservation of momentum. The first one is Newton's cradle. The Newton cradle is an example for elastic collision. If we lift the sphere at the end of one side and release it, it will smash the middle sternareal sphere and transmit the pressure to the last sphere, and that sphere will be hit upward. And since it is elastic collision, so the velocity that the first ball hits the other spheres will equal to the less spheres velocity go up. And the other application is multi-stage rockets. Multi-stage rocket will have 2 or more rocket stage, and each of rocket stage will own its own engine and propellant. And during the rocket flight, each of rocket stage will burn its own propellant complete and take off in order. And since the rocket stage take over, the mass of rocket will decrease. And by the conservation of momentum, the velocity of rocket will increase. Let the rocket fly higher.
Seriously?
Yes, and that is yes. Since the rocket stage, yes.
Okay, can you go back?
Okay.
So you're talking about M1 and M2, right?
Yes.
In 3 cases. But in rocket, what is M1 and what is M2? Can you go to rocket now?
Rocket.
Yeah. So what is M1? What mass is M1 and what mass is M2?
And before the rocket take off, the whole object is M1 plus M2.
Okay.
And after the first stage separates, and the N1 will be this, and N2 will be the other that doesn't take off.
Incorrect. Okay. Figure out what is M1 and M2 here, and then why rocket goes farther. Okay.
Oh.
Yeah. What the experiment is wrong. Sorry. Incorrect.
Oh.
Okay. Okay. So for example, say I don't know, say airplane flying, right? Say it's a military airplane, and people jump off, right? Does the airplane go up? No. No, right? Airplane's here, right? You drop something. So from airplane, you drop something. You go up? No, right? It's the same thing. Rocket drops the booster, it doesn't go up. So figure out what is making rocket higher. Okay. What is M2? Okay. All right, go on.
And back to the question that we talked. Since we know the equation for conservation of momentum, we can write down this equation to show the relationship between the velocity of eggs and birds. And since it looks like it follows the law of conservation of momentum, but I'm curious that whether it is. So next, we will check whether the bird is really follows the conservation of momentum. And the way we check is we will use the velocity with egg and bird with y-axis to find the ratio of the mass. and we will use the velocity with y-axis to calculate the other ratio. And we will compare these two ratios to check whether it follows the conservation of momentum.
That's good.
And first, we use the velocity with y-axis to check to calculate the ratio of mass.
You measure pixels?
Yes.
That's good. I like that. Yeah.
And since after using the bird using power, the egg and bird will still affected by the gravity. So we measure the distance starting from the central.
Okay.
So now the distance is only affected by the initial value, the egg initial value and bird initial value.
Mhm.
And to make the calculate easier, we will use the power at the top of the parabola. So the initial value with y-axis will equal to 0.
Okay.
And using the equation that we get and put the distance that we measure, we can get a ratio of the mass will equal to 0.852.
Wait. So the distance you measure blue and red, and then that's the velocity that you put it in. So the 127, 149, you measure, right? That's red and blue distance.
yes, red and
right? So you assume that's the velocity?
Yes, because they have the same time.
Okay. Oh,
And
okay.
we
but what about the gravity here?
not because we measure the distance by the centroid. So here is we use the power, and there is a half an hour ago. And here is the bird that if she didn't use the power, she will be there. So we use there to study to measure the distance. Since these three objects were affected by the gravity.
Okay. So you measure distance not from the initial point, but then
The central there.
okay. But is that okay? Gravity is accelerating force.
Yes, but
If it's a constant movement, that's okay. But then is that okay?
gravity, the effective gravity won't. Because for no matter how the mass it is, the gravity will give the same effect.
Yeah, but then it's in the opposite sign. No? So the distributed initial velocity when they are separated, right?
Here is a initial point that they separate.
Right. But then afterwards, then the bird is going to be slowed down because of gravity, but the egg is going to be accelerated, right?
No, but the gravity effective will be the same direction for those three objects.
Right. Can you show there? If that's okay.
Right.
Here. Well, this is a good example, right? This is why we use equation to understand.
And bird will be uh,
下面的弹幕加快，上面的秒会变少。
其实完全不是手的这种中医的问题，是你点下去就会可能长一万对，所以它的形态那比较轻微，我比较倾向于是它，你可以从那个踢下去看，
we let the upward be positive and downward go
比较倾向于这样。
and great distance will be the bird minus the no power and
So you're talking about this is the position, right?
可是
This is position, right?
我不见得，
then
它是上面。
then here be 0 and go upward is positive and down is negative.
But you're talking about velocity here. You're talking about velocity, not position.
Since they have passed the same time. So
Yeah, but you sorry, B. Okay, fine. Okay, you do it in a report because we don't have much time. You can write add this to your report. Okay. And then so the mass ratio you talk about a 0.852.
Yes.
So does that mean egg is larger than the bird? Egg is more massive than the bird?
yeah, the egg is heavier than the bird. No, the egg is lighter than the bird. That is a ratio of the mass of egg and bird.
Okay, sorry. It's free, so, okay. But it's gross, 80%. Okay.
And next, we use the velocity with x-axis to calculate the ratio. And since the egg goes straight downward, so the velocity of egg will be 0, and we can get this equation. And also, we measure the distance for the bird didn't use power or after using the power, and we can get this equation and calculate it. We can get a ratio of mass will be 0.287. And since these two ratio, the difference of these two ratios are too big, so that we can have a conclusion that the bird doesn't follow law of conservation of momentum. And here is my report.
So this, you're considering x velocity now, right? And then, so the egg is going straight down
Yes.
from that point, so that's why you measure the velocity of Bx is egg is 0.
Yes.
And then the velocity of the bird you measured. What is this? So the blue is 120 and red is 87. So actually, the blue one got accelerated. Blue one got accelerating faster.
Blue one is the bird using the power. Then, since the egg doesn't have the velocity with x-axis, so the bird will be faster on the x-axis.
No. But then egg had initial velocity, right? Where did the initial velocity of the egg?
V0.
Oh, yeah, okay. Yeah, but then it should still have that velocity, right? Why it becomes zero?
No, because it goes straight down, so down.
Yeah, it shouldn't go straight down because it had initial velocity. It went backwards. That's why it get the backwards velocity. That's why it went straight down, right? So you need to consider that in here. Okay, you know what I mean? So the egg went straight down. So if you drop an egg from airplane, egg is going to go forward, right? Because airplane got the speed, right? So if you drop it, it doesn't go down. It goes down front, right? Okay, but in this egg went down straight, right? So that means
The bird will go fast.
yes. So bird throw the egg backwards, right? That's why it got straight down. Otherwise, it could move forward, right?
Yes.
So that's why the blue is moving. Blue is faster than red, and you're missing that here. So I think this game is actually trying to conserve the momentum because egg went straight down means the blue should be faster than the red. That
But
makes
it
sense.
should be more faster if we use the ratio of the mass that we got here. The blue this
But
mass
that-
should be more large, more bigger.
Why? Where is it?
Because the ratio of the mass we got here is 0.852.
Right. That's good.
So here and this bird is that she doesn't use the power, so the mass here is the bird plus the egg, and here is only the bird.
Right. Okay.
And so this bird, the mass of this bird will be the mass of this bird 1.852.
Mhm.
But the ratio of the red and blue distance doesn't be this.
Well, it depends on the initial velocity, right? V0, it depends on the V0. If V0 is large or small, then the difference between red and small is going to be different.
But this equation will be by conservation of momentum. This equation should be accepted.
No. So I'm saying you're missing the Vx egg is not zero. Vx egg should have a velocity, right?
But after using the power, because it goes straight down, so it means that its velocity with x-axis will be 0.
Ah, okay. Okay. Android. So VX bird, which bird did you use?
This
Okay. That's good.
this is 0. Since that bird doesn't use the power.
Oh, okay. Sorry. I think your equation is correct. I think. Yes. That's good. Okay. Okay. Then you get a different ratio. And then you're saying if the ratio is 0.8, the blue should be farther ahead.
Yes.
Okay, that makes sense. Okay, good, good.
And because the difference of the two ratio is too big, so the bird doesn't obey law of conservation of momentum.
Right. It's a pity, isn't it? I don't know how they didn't calculate this in the game.
But because the calculator I ignore the error resistance.
That's fine, Laura is going to hear. Oh, it's a pity. I mean, maybe you should send an email to them and then ask them to figure this out. I mean, it's not difficult, right? You just make this correct, right? Blue is a little bit faster, then it makes all sense, right?
Yeah.
Oh, you should send an email to the author. Okay, good, Stanley.
Okay.
I like what you did.
Okay, so as the game gets popular among the people, the developer also provide a special edition called Space. So, yeah, I'm keeping.
It's this version.
So you can see there's a planet surrounded by a mysterious blue shell, and the bird will fly and go into it. It will turn. So according to my observation, I think that this including the inertia, gravity, and energy. These concepts.
I need the power. I'm running out of power.
Okay. So first, I will talk about inertia because before the bird enter the shell, the bird will fly straight. So this is because there's no force acting on the bird. So the bird will remain its motion. So this is related to the Newton's first law. Then,
There's no gravity from that thing?
because it flies straight. There's no, I think there's no force, but
Okay.
I will discuss about this later. And when a bird enters the shell, it will feel some force and start to rotate around the planet and hit the peaks. This is, I think this is because of the gravitational force. And this gravitational force, according to the equation, is proportional to the mass of two objects and inversely proportional to the distance squared. And why the trace is eclipse or circle? Because there's initial velocity and the force is perpendicular to the velocity, so they will try to rotate around the planet. Then, I also observed that the mysterious shell, the blue shell, is independent of the birds. In other words, if I choose another one, the shell will not change. The size of the shell will not change. So maybe it is related to the field, this concept, because the field, according to the equation, it excludes the factor of the birds. So it's only related to the planet. And yes, and in other viewpoints, we can also explain it about energy. Since the birds will stick on the slingshot first, and when the player releases it, the birds will propel and will be projected and fly. So I think this is very similar to a spring because it has the potential energy on the slingshot. And when the player releases it, the birds will get some energy and start to fly. And okay, but when the bird enter the shell, the blue shell, it will get some potential energy since there has some gravitational field. And according to the equation there, you can see the potential energy is reversely to the distance. So when the birds gets closer and closer to the planet, the potential will be in decrease, and the potential energy will convert it into the kinetic energy. So it will get fire faster and faster and hit the peak. And according to the plot on the bottom right, you can see as the distance closer, the potential energy will decrease and the kinetic energy will increase. Yeah. So, but there is something maybe not make sense, because according to the field equation, you can see that there's no limitation about radius, about the distance.
Right.
So yes, the field can be affect at infinity, and yes, so there's there's no limitation about range. So maybe the developer should not define the boundary of the field. So yes, I think this is something that we can think about that twice, and as a little bug in a game.
Why did they introduce this boundary? Any idea? Why did they use this boundary?
Because I think that they want to introduce a gravitational force or field concept, because the Earth will go into a sphere and start to rotate around and goes closer and closer to a peak. And in this shell, the bird can accelerate and start to turn to change their direction about motion. So maybe they want to change the motion of the bird, or the
Or can you do that without a boundary? It happens even without boundary.
if there's no exact boundary, the birds will start at the beginning of just after they leave the swing track. They will start to turn.
Yes.
And yeah, but if is a boundary, they will start by flying straightly, and by after enter the shell, they will start to turn. So there's a little bit difference, between from the reality. And this is my part, and this is our work list.
Okay.
Yeah.
So Gigi, maybe can you consider what happens to the game if there's no boundary? Can you explain a little bit? You already did, but maybe can you add it in the report?
In words, put in words. Okay. So,
Good. Very good.
but yeah, we run out of time.
Yeah,
Yeah.
but we have quiz.
Yeah, we have some. We have a slide of
Okay.
we did that. Yeah. So should we show the screen?
Yes, I mean,
Or
you should do it, no?
oh, okay. 那等我一下。
I don't know if online people can stay or not.
Yes. Present. Wait a second.要怎么用？
不知道，我没用过这个。
Let me try. 是这样吗？我看一下。这是要把它移过去。
哦，对对对，好像这个样子。
要分享那个画面。
Okay.
Only one.
Good. Online people also please join.
Um. Two. Only two of them. Yeah.谁乱讲
What is people?
Here.
Did you join?
Okay,
Yeah.
I the people online.
Okay.
Okay. So. Wait a second. 应该没有人讲。
可以啊。
Should we get started?
Yes,
Yeah,
let's get
okay.
started.
There's only 6 questions. Okay, the first one, the maximum speed of the angry bird is. One second remaining. Oh, most of them choose C. So which C is the correction.
Oh, good.
Okay, the second question. Which type of collision obeys the conservation of momentum? 5, 4, 3, 2, 1. Okay, so review. D is the correct answer.
Okay.
Okay, because every type of collision will obey the conservation of momentum. Okay, the third question. What's the relationship between gravitational field and distance? So the answer is D. Is reversely proportional to R squared. And the fourth one. The chalk. What's the motion of the chalk? Chalk
Is it white
is
one?
white. Is the yellow one.
Oh, I have no idea. Then.
Well, the correct answer is D. The tangent. It will accelerate along the tangent line.
That's tough.
Yeah, that's the chalk. Okay, the fifth question.
Did you explain it?
In the beginning, the very, very beginning of our report.
I don't remember.
Which country?
They're not Taiwanese?
No. Oh, the correct. Oh, wow, 50-50. The correct answer is Finnish. The Finland
is
is
kind of a
Finland.
small country.
Yeah, but they developed a famous game worldwide, I think. Yeah, most of them. And the last one, what's the main difference between the two? It's negative. So let's see the results. Oh, the correct answer is C, the error for your section. So the leaderboard is the people of night.
Okay, so who is the top without out of your group?
people over 你要
哪些不是哦
Anya is here.
Anya is online people.
I can online people 没有是我。
Stanley.
Stanley.
Sarah.
How about Zizi?
Gigi.
No, I'm Kitty.
Oh,
Hello? Oh,
what's just still my name? Z. That? Z.
who's Zizi?
Maybe online people.
Okay, you're the top. So
Yeah.
just congratulations.
Congrats.
Send here an email saying you're the top. Then you get the point. Okay,
Congrats.
good. Thank you very much. I
Thank
think
you.
your presentation was very good. Okay.
Thank you. OK，到，快没电了。
You're finished?
Finish.
Thank you very much.
Thank you. Thank you.